Hi everyone. Welcome to the Geeky Minds, your source for things related to system design and back-end development. If you are new here, I'm Gourav, a back-end developer and your new friend in the tech world. Let's explore and learn about system design and back-end development together. Don't forget to check out my blog, https://thegkyminds.com for even more great content. And please don't forget to like, comment, and most importantly, subscribe, so we can continue this amazing journey together. So grab a cup of coffee, kick back, and let's get started. What is an idempotent API and how to use it? APIs have become a fundamental aspect of modern software development, allowing different systems to exchange data and communicate. However, with the growing use of APIs, it is becoming increasingly vital to ensure their dependability and effectiveness. In recent years, Idempotent API has gained popularity as a means of constructing more robust and trustworthy APIs. However, what is an idempotent API and why is it essential? In this video, we will discuss idempotence and what it means for an API to be idempotent. In addition, we will explore the advantages of idempotent APIs and the many ways for implementing them, such as the usage of HTTP methods, unique request identifiers, and error handling systems. Let's dive right in. What is an idempotent API and how does it work? An idempotent API is a type of API that allows for an operation to be performed multiple times without changing the result. This type of API design can help developers ensure that their applications are more reliable and efficient, as well as provide a better user experience. In API design, idempotency is achieved by making each server request return the same result regardless of how many times the request is made. This means that performing an operation twice or more will not have any additional effect beyond what was intended. This reduces the time required for operations and results in fewer errors. Why do we need idempotent APIs? Consider a scenario in which an application initiates a task to generate a token for you, taking a simple example. Consider this API to be non-idempotent. When I first called this API, an error was returned. So I attempted again to call this API. This time, the API was successful and generated a token for me. The issue is that the API returned an error the first time it was called, although it is possible that the API created a token in the backend but threw an error for another reason. If this were the case, I would have created two tokens instead of simply one. Imagine that if this API was idempotent, it would have created only one token for me regardless of how many times I called it. This is why we require idempotent APIs. For the first case, multiple payments were sent out because the API used was a non-idempotent API. What does idempotent mean? Idempotent is a mathematical term used to describe an operation that, when repeated multiple times, has the same result as if it were executed only once. In the context of APIs, idempotence refers to the property of an API where multiple identical requests have the same effect, regardless of how many times they are executed. For example, sending a GET request to retrieve a specific resource should return the same result, no matter how many times it is executed. Sending a PUT request to update a resource should have the same effect regardless of the number of times it is submitted. This enables API customers to retry failed requests without worrying about unexpected outcomes, such as numerous copies of the same data being created. Idempotence is an essential attribute of APIS that ensures data consistency, reliability, and stability, making it a crucial factor in API design and implementation. Advantages of using idempotent APIS. Improved reliability. Idempotent APIS can gracefully manage network problems and other failures, ensuring that data is processed successfully even under adverse situations. Better performance. Multiple identical requests will return the same response, allowing idempotent APIS to exploit caching to increase performance and decrease server load. Scalability. Idempotent APIS are better equipped to manage high traffic and large-scale processing because they reduce the likelihood of data duplication or inconsistency. Easy error handling. The idempotent nature of APIS makes it easier to handle mistakes and incorporate retry mechanisms, hence enhancing the system's overall stability and dependability. Idempotent APIS are especially useful in situations that support microservices and serverless computing, where the state of the system may change swiftly and unpredictably. As a result of the above, idempotent APIS also improve the safety of APIS and hence the system. In conclusion, idempotent APIS serve a significant role in maintaining the consistency, dependability, and scalability of data processing systems. Designing the API to support idempotence. When building an API, it is essential to determine which operations should be idempotent and to design the API accordingly. Specifically, actions that modify data, like as put and delete requests, should be designed to be idempotent, but operations that retrieve data, such as get queries, should be idempotent by design. Using HTTP methods, get, put, delete, for idempotence, HTTP methods such as get, put, and delete can be used to implement idempotence in APIS. Get requests are inherently idempotent, as multiple identical requests will return the same result. Put and delete requests can also be made idempotent by including a unique request identifier, such as an e-tag, to track the state of the resource being modified. A unique request identifier, such as an e-tag, can be used to track API calls and guarantee that subsequent similar requests do not create unintended consequences. Error handling and retry mechanisms. When implementing idempotent APIS, it is essential to provide error handling and retry mechanisms to ensure that failed requests are retried until they succeed. If a put request fails due to a network fault, for instance, the API should automatically retry the request until it succeeds. This ensures that data is accurately processed, even under harsh situations. Implementing idempotent APIS, in conclusion, requires careful consideration of the operations that should be idempotent. By considering these aspects, it is possible to design and build APIS that are consistent, scalable, and trustworthy. Use cases of idempotent APIS. Microservices. Microservices designs rely on a large number of small, independent services that communicate with one another to create a comprehensive application. Idempotent APIS enables services to handle errors and repeat failed requests without introducing data inconsistencies. This contributes to dependability, scalability, and ease of maintenance. Serverless computing. Serverless computing is a model in which programs are developed and executed without requiring dedicated servers. In this scenario, idempotent APIS are essential to guarantee that failed functions can be retried without creating data inconsistencies. Payment processing. In payment processing systems, idempotent APIS are crucial for ensuring that payments are completed accurately despite network problems and other difficulties. For instance, A payment API may be built to automatically retry a rejected payment. Network devices and IoT are frequently used by network devices and the Internet of Things, IoT, to communicate and exchange data. In this scenario, idempotent APIs are crucial for ensuring that data is successfully processed regardless of network circumstances or failures. A smart home API, for instance, may be built to automatically retry a request to switch on a light until it is successful, without duplicating the request or causing other irregularities. Idempotent APIs are beneficial for a variety of use scenarios, including microservices, serverless computing, payment processing, and network devices. By ensuring the accuracy and consistency of data processing, idempotent APIs play a significant role in the development and design of modern applications. In conclusion, understanding the benefits of idempotency is crucial to optimize the usage of APIs, which have become an important element of modern web development. Idempotency ensures the accurate processing of API requests, even when they are received multiple times. Idempotency also helps to reduce the server load by allowing requests to be processed swiftly and efficiently. By comprehending the significance of idempotency in APIs, developers can construct apps that are more resilient and better equipped to handle enormous amounts of traffic. And that's a wrap. Hi, I am Gourav Dhar, a software developer, and I create content on back-end development and system design. Subscribe to my newsletter and learn something new every week.